Oh, no.
It's
Okay,
I'm
well,
gonna come
part
in
of it,
5 minutes and we'll get it fixed.
part of it is similar.
That's pretty unclear because
All
I
right.
don't remember Chem 2.
So here's how this is going to play out, okay? So we've got one more test over quantum mechanics,
This way.
okay? And that's going to take us about 2 weeks to get through, okay?
Let's take 5
But
weeks.
here's where this gets wonky because like the AP chemistry test, you got the AP physics test, and you've got some things that are going to play into this, okay?
No, you would not. Don't even.
So, in terms of when the test is going to be, I got to see how that's going to fit with some other things. But it's probably going to be like after the AP test is done, but obviously before the seniors. Okay? So the seniors' last day is what, like April or May 12th? Okay. So I'm guessing it's probably going to be either that Friday or Monday, something like that in that range. It's not going to be the last day. Okay? I promise you, I'm not going to make you seniors take the
No,
test
like the Friday.
on your
like,
last day of the last
Love you,
class.
Not the 11th, not the 11th.
I'd love to, don't get me wrong, but I'm not that big of a
Can
jerk.
you do it that Friday before? No Monday test, please.
Oh, yeah.
Just,
Bro, I would take it.
I agree with
I'm hearing no test.
oh, there's going to be a test.
What if you just
Wait, actually, can we not do it Friday?
Says nobody
What if you just
ever.
put it after the senior row?
Wait,
If
actually,
only.
I don't really
Where
want
we
it
put in
Friday.
4
I
hard
changed my
years,
mind.
yeah, hard work and
I have an
dedication.
AP
I
test.
feel like that
Oh,
we
yeah,
need
you
to
don't.
calm down.
I have an AP test on Thursday.
I think
Okay.
Gavin needs this, bro.
Let's do
So-
Wednesday. Let me check my calendar.
All right. So, quantum mechanics, and it's one of the strangest things that exists, mainly because even Einstein hated the idea of quantum mechanics. And if there's ever a debate that happened in science, it's this whole idea of quantum mechanics. As you get into some really, really weird stuff, you can get it into entanglement. They try to reconcile like gravity with what happens on the quantum scale, and you can't because everybody wants one equation. They thought, oh, we can find one unifying equation that we can put on the back of a t-shirt and go, the universe happens because of this. We wanted one equation that would unify all of the forces. And it just turns into a train wreck.
Just like Albert.
A squared plus B squared equals C squared. No.
So, one of the things that gets weird about this is there's any number of things. And this is one of the very few topics that the more I studied it, and I've studied it a long time, the more I knew about it, the weirder and stranger it gets. Okay? So let me give you like a simple example. So if you look at what has to happen for you to have skin, let's just start with this. What has to happen for you to have skin? On an atomic level, what has to happen?
Bonds.
You've got to link together carbon atoms,
Trash.
or some type of atom, right?
Trash.
They have to link together. Okay? And the cool thing about your body is if you cut your skin, your body has the capacity to heal it, to put those atoms back together. Right? It's kind of cool if you think about it. You scratch the paint on your car, hey, it's not going to heal itself.
Nope.
But you get a scratch on your hand, it's going to heal itself. Okay? So, atoms that make up your skin obviously have the capacity to bond together, because if they didn't, you wouldn't have skin.
Oh,
I'm just saying.
that's
Okay?
quite interesting.
It's true. Now, so atoms that make up your skin obviously bond together. But at the same time, they don't. So if I take my thumb and my index finger and rub them together like this,
Friction.
okay, it generates some friction. So the atoms that make up the skin here are linked together and hold that together. Obviously, the same thing is true here. It's all skin. But if I try and merge these two together, they don't.
Get your skin.
So the atoms have a unique ability to bond together, and yet at the same time be repulsed by each other.
I have a for real question.
Well,
It's like,
No.
this is something I've seen.
Hey, let him out.
So, if you like pure metal, two pieces of pure metal, you like go in space vacuum, and you put them together, do they like use?
What?
Because they can't tell the difference. You know.
Like, hopefully everyone.
Where
we getting this from, bro? Where we get this fusion?
They don't know what kind of metal they are, so they just
Well, it's just it's two pure metal. So the atoms
so here's my point.
go together.
That's because they're absolute.
Okay,
Wait, he's got a good question, guys. Schrodinger's step is the version. Wait, is he Loki right? Shut up. No, think about
A
it.
person who thinks all the time is different.
Bro, let him explain.
Hey, Nathan, you moved the table.
Oh my god, I'm so sorry.
Nate, lock in, bro.
Is
Yo,
it,
your
is
voice
it still in
is like-
English? Or
No, it's fine.
frame?
I'm just making you aware.
Okay, I'm so sorry.
I just laughed.
Yeah, I'm going to that.
But seriously, my apologies.
No.
It's way worse.
Did you?
okay.
I
So
think he
those
never
of
got
you that are in
loud.
chemistry,
Why was he freaking when he left?
so let's talk about like the scale involved. So if you take this piece of aluminum forward, and I'm not talking this dimension, I'm talking like that edge right across there.
Oh god.
Like a couple atoms.
If you do the math,
More like a
that's about 94,000
No, that's it.
atoms across this edge right here. Okay? That isn't this edge, that's that edge.
like up and down.
Okay?
We use like the thickness, is that what
Yeah, like right across here. This thin edge right there. It takes about 94,000 atoms stacked side by side by side by side by side to get that thickness. Now, to scale, if I stretch out my hand and let this be the size of one of them, okay? One of them. This is the outer edges of its electron cloud, the Chihuahua cloud.
Yeah.
To that scale, a human hair, I would sacrifice a hair for you guys. Oddly enough, it's gray. Wow.
Wait, Burkamp, whose name is on it?
Oh, Opie, it's
Oh,
all
gosh.
you, girl. Okay?
Should have asked.
Yeah, you asked, I told. So, to this scale, that's the size of the nucleus.
Oh wow.
Okay? So here's the size of the atom, the entire diameter. This right here, that's the diameter.
You know how big a
So-
proton would be?
Basically, you're telling me everything's packed into this, and all the electrons are the big thing.
We're not 99% empty space.
Yeah, makes sense.
No, it doesn't.
It does.
No, it's not. That's a bold-faced lie.
Hey, we're gonna go into why that doesn't make sense.
Physics, man.
No, this is why it's a bold-faced lie.
Oh, goals play experience. We're gonna walk on
Okay? In terms of what you intuitively understand. This is the weird part about quantum mechanics. Is that if you look at this, it's like, man, this feels solid. I can't see through it. Okay? Right? It has some flexibility to it. But again, this is a situation where you have bonds that hold the atoms together, but yet, if I fold this over and do this and try and press it together, what happens? Nothing. This just unfolds. So they're held together, but yet they're not.
See?
So-
Just like Gavin said.
When you were talking about like,
They're held
the
together,
human
but-
Hush!
When you were talking about the human hair to scale, was that the nucleus or like the atom as a whole?
No, that was just the nucleus. So this edge to edge, okay, fingertip to fingertip
It's a good drawing.
Is that
is the entire Chihuahua cloud. The nucleus is right there.
so the protons and the neutrons exist in just that nucleus cloud and not
Yes.
the-
Everything else is created by Chihuahuas. Okay? So this is why this was so hard to get. Now, if you look at what Ernest Rutherford did, Rutherford shot the alpha particles at the gold foil. Now you can understand how Rutherford did this. So what Rutherford did is that he had a radioactive source, like thorium-238. And it would randomly decay and kick out alpha particles, which we found out later, or a helium nucleus that's positively charged. It's stripped off its chihuahuas. It's just the nucleus. He called them alpha particles because we didn't know what the element helium existed at that point. We did not know helium was there. Anybody know the origins of the element helium?
From
Stars.
Huh?
From two hydrogen going together.
Fusion in the
No,
sun.
he means how they found
The Big Bang.
it. He means
The
how they
first
found
time we discovered helium was when we looked at the atomic spectrum of the sun.
That's what I just said in the sun.
it. No, you were
But it had, you're right.
Hey, you're flying a little too
Okay.
close to the sun right now, pal.
So
Incorrect.
what we saw, because remember, if you remember back in Chem 1, each element has like its own unique spectrum, okay? Which we'll talk about later. But so helium has its own unique spectrum, and we've never seen it before until we looked at the sun. And we're like, oh, that's why helium is named after the Greek word helios, which means sun.
Oh.
Now, the reason that it was so hard to find helium is for two reasons. Number one, it's exceptionally light. Okay? Number two, it's also a noble gas. So it's a very, very light, very, very rare noble gas.
What?
Okay? What?
Why does helium make our voice higher when we inhale it?
Because it's less
light.
dense, so
Yeah.
your pitch vibrates at a higher
If you go like,
volume.
if you like breathe in like.
Hold on, take it out.
Now, so little story about helium. The first real major source of helium was actually out in southwest Kansas. Okay, this is during World War I. So, and that was kept as a national secret.
First in the world?
Yes. The
Was
first
it
like
just-
big large supply of helium was found in southwest Kansas in the natural gas field. So, and it don't think that, oh, they just found a pocket of helium. Helium was mixed in with a bunch of other natural gas.
Yeah.
But what they do is that they would take that collection of natural gas and they would run it through a big column and they would cool it down. So the more heavy gases would coalesce first because they're more sticky. Helium isn't very sticky. Helium is the
It's best model.
coldest liquid on Earth because helium atoms are not very sticky. So this is why it's so hard to separate helium because you have to get it so incredibly cold. So typically, like a good field of helium might have like 5 to 6% helium mixed in with everything. This isn't like, oh, we're going to go prospecting for helium and try and find it, okay? It's always mixed in with something else. So the reason that was kept a national secret is because during World War I, they needed them for the hot air balloons, for the lighter than air ships. Because they didn't want to use hydrogen because of like, the
Flammable.
Hindenburg, for example. So helium has the advantages of being lighter than air without the reactivity of hydrogen. So this is why they kept that a national secret, the fact that we were sitting on a big helium deposit out in southwest Kansas.
Do we get paid good though?
I don't know. I don't know the finances. I know the military pretty much hijacked it.
Oh wow. That's
So-
nice.
Typical.
It was
So-
Economics.
Now you can understand what Rutherford did. So what Rutherford did, before he shot him at the gold foil, he needed to have them go in a straight line. So he had it inside this box, and there was basically an opening, okay? But he needed them to go in a straight line. So what did he what did he have them go through?
A funnel.
Oh, an electric field and a
Magnetic field.
magnetic field.
No.
What?
No.
Oh wow.
Keep that one.
Okay? And
So like this one?
because they were going through an electric and magnetic field, he could basically sort them out. Only ones with certain mass and only ones with certain velocity would make it straight through.
Wait, is that why we did that whole question?
Does it look like this?
Now, how could he figure out that they were positively charged?
Because the direction of the electric field.
How they were attracted.
Yeah.
If they just send them through an electric field, he could easily figure out that if they were positively or negatively charged,
Exactly.
because they would deflect if they just went through the electric field. So by having the magnetic field with it, it was a great sorting mechanism. Because then only ones that had a certain criteria of mass and velocity would make it through.
It's like the sorting question.
Yeah.
Oh,
Yeah.
really?
Really?
I thought Max didn't matter.
Okay.
Nice connection, dude.
So, he shot him at the gold foil. So the cool thing about gold foil is that literally you can take it and basically make it so thin that it's basically one layer of atoms thick.
Would we be able to
Okay.
do that?
So he shot these alpha particles at them. Most of the time, they just went straight through. So to scale, imagine that you had Hank, okay?
We love him.
And Hank's in the back of the room, and the room is dark. And I've got a BB gun, and it's dark. And I'm going to start shooting BBs at the back of the room, and the only target I have is Hank.
Shot in the dark.
What's going to happen most of the time?
It's gonna miss.
It's going to go straight through. That's what happened with the gold foil. So most of the time, the alpha particles went straight through, even though it appeared solid. But now, imagine that you shoot that alpha particle, and it just nicks the edge of Hank.
Yeah.
You're like,
It'll still go through, but then it's going to get deflected, right? So every once in a while, like literally 1 in a million, it would hit and it would bounce back. Now, the graduate assistants that were working on this deal did not have a good time because this was done in a darkened room and they had a phosphorescent screen around it because you couldn't see the particles. Okay, it was the nucleus of a helium atom. So what would happen is that when these particles would hit this phosphorescent screen, you would see a flash of light. And what they would do is they would keep track of where they saw the flashes of light. And most of the time, the flashes of light, it was boring. They were literally sitting there making tally marks where they saw flashes of light. Most of them went straight through. You'd get some that were deflected more than others, but not a lot. And literally every 1 in a million, they would get that where it bounced straight back. Now, think this through. Now you can talk about energy. So here's this helium nucleus. You're going to shoot it out. What type of energy is it going to have?
Kinetic.
Kinetic. Which is going to be 1/2 mv squared, right? Cool. Now, it's going to run into this big, massive gold nucleus, right? Even though its nucleus is a big nucleus, it's really small, but still very massive. So that's going to hit, and it's going to bounce back. So what had to happen to all of that kinetic energy?
Transfer.
No, change into what?
Potential.
What kind of potential?
Light.
No.
Spring.
No.
Spring constant.
Gravity.
Like there's a tiny spring that it hits?
Like
us. Like electro.
Not us.
It stays
Oh,
kinetic.
oh,
It just moves the other way.
Electromagnetic.
It has to spot.
no,
So the kinetic has to go 0. at some point.
Yui!
Electric?
You said potential. I said electric.
No, I just heard potential.
How is that?
I never heard of that.
I heard it say electric.
Okay, but like
I heard him
obviously.
say- I heard him say electric.
How do you calculate Yui?
I don't know.
Okay, Q1, Q2,
Over
B
R.
squared.
J squared.
A D.
This distance.
Oh, wait. Oh.
Because if you're
I think
divided
about
by
K
d
cubed
squared,
R
you get
squared.
force.
Oh.
That's a secret.
So, here's the cool thing. If you know how much kinetic energy that you have, you know
How much you?
Wow.
how much ooey that you have.
Oh, wow.
And then if you know the charges, you can calculate that value of distance, which is called the point of closest approach, which would be the similar idea to pushing a cart, having it hit, and bouncing back. Okay? So basically it did act as a spring, but it was ooey and not us. So this created a huge problem. Rutherford's problem was this. It doesn't make sense. No, it makes no sense. Here's the problem. What's the atomic number of gold is like a really big number.
107.
No, it's not. It's not that big.
56.
Huh?
56.
Let's go with it.
72.
79.
I don't know.
79.
Hey, it's a big number.
don't remember that so
So here's the problem with any stable nucleus. You've got a whole bunch of positively charged particles.
79.
No,
79?
that.
Yeah.
Come on. You're an A.
You have a whole bunch of 79 positively charged particles
It's 107.
confined to the thickness of a human hair to this scale. This was a problem. Why?
Very dense.
Do they want to be together?
Why wouldn't they all?
Wait, are we?
Exactly.
Oh,
yeah,
we've talked about it.
So with prom being on Saturday, imagine that you're going to take 79 girls that hate each other and you're going to put them all in the same bathroom stall.
Hell no. That's just a bunch of.
I don't like that.
Yeah, that's a recipe for disaster. But, so here's the problem. You would look at that and go, wow, this is not going to end well. I grew up with 3 older sisters. I know this. That was 3, let alone 79.
It'll be fine.
And you're going to try and get these girls that hate each other because somebody in 7th grade wore the same dress to the dance or said something on Instagram, Snapchat, whatever. They hate each other and they hold a grudge. Okay? And you confine them into this very, 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 very small space. But then they become the best of friends. If you confine them into this very, 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 very small space, they're besties. They're taking selfies.
Taylor Swift. Taylor Swift.
Okay? They are.
Oh, get that Oppenheimer quote there.
They are besties. Okay? They're besties. So, this is where they had to come up with a new force. Because you had to have a force that overcame the repulsive force, as Shaq said, that tried to drive them apart.
The strong
Gravity.
force.
Oh, they came up with gluons,
No.
We're making
The strong nuclear
We're
force.
making
which
up
make up
words.
the strong nuclear force.
Do we have to know that?
No.
I look away
We
from
got there.
That's right.
Okay?
Why
What?
is it
Blue
the
one.
axis that?
What
Or
about the
was it like the light
helium that we
axis
use.
that?
No. So, what holds the electrons around is the electromagnetic force. That's carried by photons. Okay? So the electromagnetic force, so every force has to have like a force carrier. So the only one we've really been able to, and I think this is clever, this really works the best name. So we know the strong nuclear force is carried by particles called gluons, which is clever because it acts like a glue and then holds the nucleus together. Okay? They think gravity might be carried by gravitons, which also sounds cool. We haven't been able to find them. I'm just saying. And then the electromagnetic force is carried by photons. So what keeps you from rubbing your hands together is the repulsion of the electric field carried by photons. So when you rub your hands together and it gets warm, basically you've made the chihuahuas unhappy. And they're barking at each other. They're going, hey, okay? That's what they're doing. So by barking at each other, you're generating heat. Now, in an extreme case, so if I take
What the heck?
this is
No.
covered in aluminum, and this is iron oxide,
Yeah.
and if I hit them together like this,
We didn't overcome the activation energy.
You want me to do it for you?
activation energy.
I can do it for you.
What the
But if I hit them harder,
Wow.
then
Great.
You're gonna like
Gotta like
survive.
Everyone wants
I
to be
gotta
out
end
of
up on a good one.
Great.
Oh, that was
There
good.
we go.
Okay?
We can leave it at that.
So basically what happened
I
is
need
this.
electric.
I rearranged the chihuahuas. I went from elemental aluminum and Fe2O3 into aluminum oxide
We didn't learn anything.
and iron. So I just did a single displacement reaction.
It's not balanced.
But I had to force that. This wasn't going to happen on its own. This is technically called the
Bro,
thermite
I don't think
reaction.
that's balanced.
It's not balanced, bro.
It's
That's
close
not
enough.
balanced.
You got the idea. It's a single
No,
displacement.
you need a balance.
I know.
Yeah.
Physics is not
Balance the reaction. Hey, who said that?
Add the two.
Yay!
Harsh crowd. What?
You know,
Jack had a question.
What, Shaq?
What about the weak?
Weak nuclear force, that really only plays out in nuclear decay, which will be.
Hey, dude, it's weak. It doesn't work.
Okay.
What is created by that? Like gluon.
Huh? No, the weak nuclear force is weird. It manifests itself in a strange way.
It doesn't know.
That's a whole other discussion.
Hey, oh, this is technically
Now-
made up. Have you seen it?
Weak nuclear force allows us to have a sun.
I
Without,
think that was the one that you said don't pick on the test.
oh yeah, on the honors physics test,
Oh,
I
yeah.
told you
Oh,
not
you
to
know.
pick the weak nuclear force.
I remember that.
Yeah.
I said, don't ever pick. the
Didn't
weak
somebody
nuclear
pick
force.
it?
Yeah, I think someone picked it.
I think they did.
What are you talking about?
Exactly.
Physics honors.
Now,
Oh, bro, what's
speaking
it?
of the sun,
Yeah.
here was one of the biggest problems that we faced in the early 1900s. Okay. Number one, how do you explain the fact that the sun exists and it's been burning for a long time? And it produces
Our Lord and
First day
Savior
science.
Jesus Christ.
what's the source
Amen.
of that energy?
We really don't know anything.
The bigger problem was how did the light get here?
That's a good question.
Hey, put up my Big Bang.
You brought the sun, so that is give my shot to
Yeah,
LeBron.
like,
So, what allows you to hear my voice?
Sound wave.
The air.
Sound wave. Traveling through what?
Medium.
Through air.
Yeah.
I have to have a medium, right? So when I say, hey, nuclear reactions,
Dang it.
there's a series of compressions and rarefactions that go through the air, they hit your eardrums vibrate, that goes through your inner bones, it transfers to your auditory nerve goes to the brain, and you go, oh, Brookings talking about nuclear reactions.
yeah.
Cool. It's pretty cool if you think about it.
Anatomy.
Yeah, that I got it.
Biology.
But if we remove the air in the room, any number of bad things would happen.
Oh man, we
Would
can't.
you be able to hear
We
me?
can't communicate.
No.
No,
No, it's not vacuum.
because there would be no medium through which the sound can travel.
We'd also be dead.
So we'd also be dead.
Can't even hear anything.
Don't get hung up in these. You wouldn't be able to hear my voice,
But we'd be dead.
but we'd be
I
dead.
can't hear anything.
Now, so sound has to have medium.
Get away from me.
That's why it doesn't work.
Guys, pay attention.
I have a real question.
He's ready to get 100.
So they thought there has to be a medium between the sun and the earth. Okay?
Wait, what's the difference between a medium and a median?
Are you stupid?
Wait,
Bro,
what did
they're
they say?
completely different.
This
Hey,
ain't, this ain't
Nathan, don't
bro.
lower yourself to Gavin's.
Is our also
What we just asked?
Bro, just Google that
Wait,
question.
it's a medium.
Medium, like
Like as like
Wait,
air,
talking about
air is a
medium
medium.
and-
So,
Medium, like.
Air is a
so
medium.
what they proposed,
A median is something else.
Wait, what does that say?
what they proposed
The
was
nether.
this nebulous material in between the sun and the earth called the ether. Okay? So they had to have the ether to allow the light to propagate. Now, here was the problem. This stuff got real weird. So the earth could move through it, but it didn't act like wind. So it isn't like, hey, I'm outside and it's windy and I kick a soccer ball and the wind interacts with it and like knocks it down or makes it go further. So it has no mass. It doesn't interact with anything as it goes through. It isn't like we go outside, it's like, oh, I feel the ether. Cool. Okay? So we needed it though because we couldn't explain how light propagated without the ether. So the ether was the medium. Just like air is the medium for sound, ether was the medium for light.
We made this up. We
Now-
made
Is
this
ether
up.
is that like? Is
Yes,
ether
I made this up.
medium?
That's what all of it is.
You know what I'm talking
Hey,
Now along comes a great Scottish guy,
John.
James Clerk
about? I can't remember what the Greek is. I don't know.
Maxwell.
Kirk?
I like Max.
Clerk.
Good one.
Clark Kent.
If you go to Edinburgh, Scotland, they actually have a statue of this guy in downtown Edinburgh, Scotland.
He's a god?
Okay? What?
Is the Helios sphere like the Is that what's ether?
No, the ether was existed in the gap between all the planets.
Oh, is it true?
Yeah.
Like
No. Because now, here's why they needed it. They
So it's not
needed
real.
it to explain how light could be propagated, because they didn't understand how light could propagate without a medium.
Is it a
Okay.
photon? Is it
Don't think that's.
Let's just listen.
So, this is why you have to understand magnetic and electric fields before you can really understand what happened with James Maxwell. Now, here was his thought process. And this is why you study magnetic fields.
Oh god.
So, what do you have to have to induce a current in an electric
Change in
field?
frequency.
Change.
Magnetic field.
Yeah.
But a change in magnetic field induces an
flux?
a change in the
flux.
electric field. So here's what he
Sure.
proposed. Now, this is going to take me a little bit to draw, so give me a second.
I'd like to know this.
So the ether's not coming.
Ether's bigger.
Oh.
They just
So
have.
we just made something up because we felt it.
Or can't.
What?
Do we have to know this?
No.
Yo,
Do we
why do I
even
say
have
it's
it?
so
so you
many?
can learn, bro.
Wait, do we have an
Adenine,
assignment
thymine,
today?
guanine,
Yes.
cytosine.
Oh,
Still water.
Your phone is linging.
No, don't drink that, bro. Don't drink that.
Shut up.
You'll get brain
That's
eating
me.
amoeba.
Yo, I think, wait,
Hey,
that's why I
can you
got
tell the
77.
voices
That's
to,
why I
like,
got a
get you
77
under-
because it's still.
I'm good. I already did.
He is.
I can do that. All right.
Cool, not me.
Okay.
Who's that bird? Okay.
Okay. So this is, imagine this is the electric field. Okay. So you have an oscillating electric field going like this. At right angles to this. Now hold on.
I was drawing the picture.
Wow.
You should make it
Go up
blue.
there and help him.
Oh, okay, so
Oh wow.
I'm done.
Is this one real?
He said we don't have to know this.
Half a second.
No, it's a
But
real
like-
question. Quantum mechanics.
It makes it hard.
Yeah.
The more we study this, the less we're gonna understand.
Yeah, I'm not saying
See, it only does its thing when you don't put it down.
I can just cross it out.
Hey,
Like,
is
over
that-
there, wasted
Is that
it.
cosine or sine?
Well,
Like,
like,
the
the
first one is like a heart.
One goes up, must
It's
come down.
and then the second one is like an upside down
It's a
heart.
good
And then the third one's like a heart. And then the fourth one's like upside down.
It's cosine and sine, bro.
You just
No,
don't see
we
horses.
knew this.
Okay.
It was never there.
So,
All because of an apple.
What?
so this is me trying to represent it like in a three-dimensional plane.
That stupid apple.
So the
That's
this is why it's called electromagnetic radiation. So in James Clerk Wells' model, you had an electric field that was oscillating like in one plane. At a 90-degree angle to it, you had the magnetic field oscillating at right angles to that. So this is where one induces a change in the other. So what would happen, and this is like, imagine that this is looking at this like head on. So you would have the electric field oscillating in, like, say, for example, the Y plane. Then you would have the magnetic field oscillating back and forth in the X plane. So as one changed, like if you change the strength of the electric field, that would then induce a change in the magnetic field. And it would go back and forth. So this became self-propagating because it was the change in the fields that was creating the light. And basically, the photon of light is just along for the ride. Okay? So what this did is that it eliminated the need for the ether. So this is why light can propagate through a vacuum. All you have to have, and this is the weird part, is like, is there an electric and magnetic field in space? We don't need one because it will make its own. So as soon as you create a change in the electric field, then that creates a change in the magnetic field.
But there is none.
Hold on. So when light gets emitted from the sun, it's basically starting